All right, boys and girls, it is a pleasure to be with you today. Good morning, good afternoon, good evening. Let's go with today's lesson. A big applause, a big round of applause, and a thanks to Ryan Molin for the creation of this presentation that I will share with you later on. So today's topic, guess what is it? We're talking about RAID, redundant array of independent disk. So let's go with it. We're going to learn about it. What is it exactly? What do you think when you think about RAID? What do you think it is? Well, basically, RAID is a storage technology for computers that combines multiple disks into a logical unit or a single hard drive as it appears to be to the computer. So basically, we have multiple disks that combine together. They act as a single hard drive. That's basically a RAID. Let's continue with the explanation. Why use RAID? There are two main reasons RAID is used: to increase performance, to provide fault tolerance. Types of RAID: software RAID, minimal support, cheap, low performance, high CPU overhead. Hardware RAID, widely supported, expensive, high performance, low CPU overhead. Now let's return to the previous slide. I want to show you something. What do you think is fault tolerance? So basically is to have that redundancy of the different disk and the hard drive information available for the end users and customers. More or less, that is when we are talking about fault tolerance, to have the services up and running, always up and running. That's what we need. Let's continue with the presentation. So parity, key terms: parity, equality, meaning the same thing is in multiple places. In a RAID, it means that the same information is in multiple disks and we have mirrors of that information. This is the redundant aspect of RAID. Stripping sequencing, meaning that every member gets a piece of the pie. A round-robin methodology is used. Blocks of data are spread across disk in sequential order. This is the performance aspect of RAID. Let's go with the most common RAID configurations. I need to move myself from there for a little bit so you can see better in the presentation. So the most common RAID configurations are RAID 0, RAID 5, RAID 1, and RAID 10. Let's continue. RAID 0, we are talking about block level stripping without parity, redundancy. It requires two hard drives. Data is written to each disk in sequential order, no redundancy. If one disk fails, all data is lost. Very high performance. No error checking. Ideal when performance is the only concern. Okay, so we are talking about RAID 0. In this case, what happens if the one disk fails, the data is lost and there is no redundancy. Now let's continue with RAID 1. We have block level mirroring, redundant. It requires two hard drives. So the previous one required two hard drives, but it doesn't have redundancy of if one disk fails, the data is lost. Let's see what happened with this one. So the block level mirror, we are talking about a redundant scenario. It requires two hard drives. Data is written in both disks. Redundant, if one disk fails, the system continues to operate. A slow read and write performance than RAID 0. So it's ideal when fault tolerance is a priority and performance can be compromised. Allows a single disk failure. So in this RAID 1, we are allowing a single RAID failure only. That's basically RAID 1. Let's talk about the next one, RAID 5. Block level stripping. Whoa, block level stripping with distributed parity, redundant. It requires 3 hard drives or more. Data is reading to all 3 disks. Redundant, if one disk fails, the system continues to operate. Best of both worlds. RAID 0 and 1, RAID to read and write performance with redundancy. So we get the best of RAID 0 and RAID 1 in a single location. We're talking about RAID 5 now. It is ideal when fault tolerance and disk read is required, as well as write performance is needed. It allows for a single disk failure. We're talking about parity across disk. Let's continue with this. And we have finally the RAID 10. Block level mirror set in a stripped set considered a hybrid of RAID 0 and RAID 1 redundant. It requires four hard drives or more. Data is mirrored and stripped to all 4 disks redundant. If 2 disks fail, the system continues to operate. It's very high read and write performance, considerable disk capacity wasted as a result of redundancy and performance characteristics. It is ideal when talking about multiple disk failures, protection, and very high read-write performance is needed. It allows for multiple disk failure. So let's continue. Let's see what is going on. Now we're talking about space. Very important topic here. The resulting usable disk capacity. We are talking about 1.86 terabyte for RAID 0, 9931 gigabytes for RAID 1, 1.86 terabytes for RAID 5, and finally 1.86 terabyte for RAID 10. So that's basically, so you have an idea about the disk capacity for each of these RAIDs. And finally, we have the other RAID technologies, RAID 6, RAID 50, 60, and 100. Let's talk about them. So if we're talking about RAID 6, we are having 4 drives. Block level stripping and double distributed parity. RAID 50, 6 drives. Straight block level stripping and distributed parity nested. RAID 60, 8 drives. We're talking now about 8 drives. Straight block level stripping and double distributed parity nested. And finally, we have the RAID 100 with 8 drives as well. It has a strip of RAID 10s in a nested environment. And that's basically everything that we have to cover up today. It's only theory, I know, it's very boring, but we will be doing some practice and learning about this. I will probably be using flash drives with good capacity in order to run these labs. So I see you around, guys, boys and girls. Have an amazing week. Take care, guys, boys and girls. I see you around. Goodbye.